Right. So this next equation that we're solving for, chapter 27, is 18. It says at what speed relative to the laboratory does a clock tick at half the rate of an identical clock at rest in a laboratory? Give your answer as a fraction of c. Okay, so we're going to have to calculate this with the equation t equals time proper times gamma. So what we do know, we know that the time is going to be twice as slow as this time, right? So basically you can write an equation where, let's do it like this, time proper equals, no, time regular, sorry about that guys, time regular equals 2 time proper. Okay, so we can actually plug that into this equation. We have 2t proper equals t proper times gamma. So we can cancel out the t's by dividing by time proper. We get 2 equals gamma. Now gamma, as we know, equals something else. So we can go ahead and throw that into the equation. So we have 2 equals 1 over the square root of 1 minus v over c squared. So basically if we times that for here, we get 2 times the square root of 1 equal over, 2 times the square root of 1 minus v over c squared equals 1. Okay, and then we got the 2. We have this equals 1/2. Sorry, just going to have to write it over because this is kind of complicated algebra. Then we want to square this. So we have 1 minus v over c squared equals 1/2 squared. Following me so far? So we got this 1 that's in the way in the negative, so we'll subtract 1 times negative 1. So we get vc squared. We're getting closer. Equals, it's going to be 1/2 minus 1 times a negative 1, so it's going to be, I believe it's right, it's going to be 1 minus 1/2 squared. Follow me there? Because it would have been 1/2 squared minus 1, but since we times everything by negative 1, it would have been 1 minus 1/2 squared. Okay? And then we take the square root of that. Sorry, my parentheses are awful. And that's just numbers. I mean, we can do the math on that. And we get 0.866. And so that is the fraction. So the fraction is what they're asking for. They're not asking for the velocity. So the ratio of v over c is going to be 0.86, or basically the velocity is 87% of the speed of light. That's how fast it'll have to be to have their time be twice as fast as our time. Make sense? Okay.